Good morning class. Today we will discuss about solid state and discuss the various terms which are associated with the solid state. So, the first thing or the first chapter, the things we are going to discuss is all about solid state. We are going to discuss about solid state. Now, when we are asking or when we are discussing about solid state, the thing which attracts our mind or the thing which comes in our idea is that the most we can see the things around us, and mainly the things which are available around us or in our atmosphere is mainly solid, or either it can be liquid or either it can also be a gas. But the maximum concentration of state in our daily life is of solids. So, if maximum concentration of anything in this atmosphere is solid, that means solids have some sort of special feature. They have some special feature, and because of those special features they are found in abundant in this atmosphere. So, basically when we are discussing about solid state, or in particularly we can say about solids. So, basically the solids are of two types. Basically the solids are of two types. The first is crystalline solid and the second one is amorphous solid. The first one is crystalline solid and the second one is amorphous solid. When the crystalline solids are further differentiated, it can be further differentiated or divided into four categories. It can be divided into four categories. The first one is ionic solid, the second one is covalent solid, third one is molecular solid, and the fourth one is metallic solid. There are four different types of solids when we are discussing about further classification of crystalline solids. These covalent solids are also known as network solids. They are also known as network solids. So, crystalline solids are divided into further four categories. For example, if we are discussing about examples of crystalline solids, for example, like we can have NaCl crystal, we can have KCl crystal, we can have cesium bromide, we have cesium bromide, we have diamond, we have copper, and after that we have dry ice, or it is also known as solid CO2, then copper, etc. These are all the examples of crystalline solids. And amorphous solids, for example, glass, rubber, cork, plastics, mica, etc. These are the examples of amorphous solids. So, these are the two categorization of solids into crystalline and amorphous. Crystalline are further differentiated into ionic, covalent, molecular and metallic. If we are discussing about the examples of crystalline solids, so the examples of crystalline solids, they have all the examples of all these four. For example, NaCl crystal, KCl, cesium bromide, diamond, copper, graphite, dry ice, copper, these are all the examples of crystalline solids. And when we are discussing about examples of amorphous solids, we have glass, rubber, cork, plastic, mica, etc. These are all the examples of amorphous solids. So, now basically let us discuss about crystalline and amorphous solids. What are the difference between these two, and what can be the other features or other points which can be a point of difference between the two. Now, when we are discussing about crystalline solids, and when we are discussing about amorphous solids, let us see what can be the point of difference when we are discussing about crystalline solids and when we are discussing about amorphous solids. So, first of all, crystalline solids have long range order. They have long range order, and the second one is they are anisotropic in nature, or they have anisotropy. The third point is they are soft and they can be cut with a knife. They can be cut with a knife because they have soft nature, they have least density. Now, in case of amorphous solids, they have short range order. They are isotropic in nature, and the third point is that they cannot be cut with a knife. Cannot be cut with a knife. And the fourth one is they are also known as pseudo solids. They are also called pseudo solids, or they are also known as super cooled liquids. Pseudo solids also known as super cooled liquids. So, these are the differences between crystalline and amorphous solids. Let us see the things which are different between the two. The first one is crystalline solids, they have long range order. Now, let us see what does we mean by long range order. Long range order means, or short range order means, so when we are discussing about any solid, the solids are nothing but they are polymers which are made up of very small units, those are known as unit cells. So, solid, any type of solid it may be, whenever there is a solid, it is always made up of some unit cells or some small particles, and those small particles are known as unit cells. So, if we are arranging the unit cells in a particular order, if we are arranging the unit cells in a particular order, and after arranging we are able to get the complete molecule or the complete solid, then the solid is said to have a long range order. But if after arranging the unit cells we are unable to get the entire solid, then the solid is said to have short range order. So, if on arranging the unit cells we have attained the complete structure of solid, so then the solid is said to have a long range order. But if we are unable to achieve the entire structure of solid, then it is said to have a short range order. Now, next thing is anisotropy and isotropy. What do you mean by anisotropy and isotropy? Let us see. Let this be the solid. Let us assume that it is a solid, and if we start moving from here to here, let us assume let the melting point here should be 100 degrees Celsius. After coming here, melting point let it be 110 degrees Celsius, melting point at this point be 120 degrees Celsius, means the same physical property. Melting point is a physical property, and when we are moving from one point to the another point, in the same solid, the same physical property is being changed. Melting point is a physical quantity, it is a single physical quantity, and when we are moving from one point to another, the same physical property is changing its value. Like the melting point at this point was 100 degrees Celsius, now here it became 110 degrees Celsius, and now it is changing to 120 degrees Celsius. If the value of the same physical quantity or the same physical property is different at different points, if the value of the same physical property is different at different points, then it is said to be anisotropic in nature. But if the value of the same physical quantity is same at each and every point of the solid, then it is said to be isotropic in nature. If the value is changing at different points of the solid, it is said to be anisotropic in nature. But if the value is constant at each and every point of the solid, it is said to be isotropic in nature. Now, the third point in crystalline solid was they are soft and they can be cut with a knife. If we have a knife, we can cut the crystalline solids, and the two halves which are obtained after cutting the crystalline solids are exactly identical, or they are exactly same to the two parts, or they are exactly same, or it can be better said as to be identical. Now, if we have amorphous solids, they can't be cut with a knife. First of all, they can't be cut with a knife, and if at all they can be cut with a knife, the two parts which are obtained after cutting are not identical at all. We cannot have two parts which are cut with a knife as to be identical. They won't have identical structures. And the last thing is they are also called, amorphous solids are also called pseudo solids, or also they are known as super cooled liquids. Why they are known as super cooled liquids? Let us see. It is because when, let us take one example. Like in case of pseudo solids, you must have observed in case of old window panes, old glass window panes, you must have observed in case of old glass window panes that the panes are thicker at the bottom. These panes are thicker at the bottom and they are thinner at the top. These panes are, you must have observed in case of villages or old houses, the glass window panes are thicker at the bottom and they are thinner at the top? It is because this glass, because I just told that it is observed in case of old window panes. So, due to heating from a continuous long period of time, due to continuous heating, this glass must have attained its melting point. This glass must have attained its melting point, and after being melted, this solid has been converted into liquid, and since gravity is acting towards downward, this water or this liquid gradually flows down, and after condensing it forms a drop or it forms a hard mass near the bottom. So, due to continuous this flow, this solid becomes thicker at the bottom and it becomes thinner at the top. It happens in case of old window panes that they are thicker at the bottom and they are thinner at the top. So, it is just because due to a continuous heating, the solid must have melted, and after being melted, since gravity is acting towards downward, the liquid must have flown towards down, and since we have a boundary over here, it must have condensed and must have formed drops or masses. So, due to this regular phenomena, this glass window panes becomes thicker at the bottom and thinner at the top. So, in this case, normally we say that solids do not have fluidity, solids can't flow, and if it is flowing, then it is not a solid. Here solid is flowing, and we have taken the example of glass. This is our glass or old glass pane, we can say this is our glass. So, since glass is an example of amorphous solid, glass is an example of amorphous solid. If glass is flowing, that means it is not a pure solid, hence it is known as pseudo solids. Pseudo means false or not real. Since solid is flowing, that means it is not a pure solid, that is why it is known as pseudo solids, and it is also known as super cool liquids because these amorphous solids, they have fluidity, and just because of this fluidity they are known as pseudo solids. Pseudo means false, and they are also known as super cool liquids because super cool liquids, they are known as just because they have fluidity or they can flow just because of this nature. So, this was the point of difference between crystalline and amorphous solids. Now, let us see the next topic. Next topic is unit cell. Next topic is unit cell. Next topic is unit cell. Let us see what is a unit cell. So, first of all, unit cell is nothing but the smallest 3D arrangement of particles. The smallest 3D arrangement of particles is known as unit cell. Just now I told in today's lecture that any solid is made up of some small particles or some units, and those units are known as unit cells. So, these unit cells are the simplest or they are the smallest 3D structures which are arranged in a particular fashion to make the entire solid or to make the entire crystal. Like for example, let us see a unit cell. Let this be the unit cell, or let us arrange in a different way. Let this be a unit cell, and this is a unit cell because it is the smallest 3D arrangement of particles which when arranged in a particular fashion, it gives the entire crystal or gives the entire solid. So, this is the smallest 3D structure, and on arranging this unit cell, the entire structure which is formed is called solid, or it is also called lattice, or it is also called crystal, or it is also known as crystal lattice, anything we can say, crystal lattice. So, again let me repeat, on arranging, this is the smallest 3D arrangement of particles. The smallest 3D arrangement of particle is known as unit cell. The smallest 3D arrangement of particle is known as unit cell, and on arranging these unit cells in a particular sequence or a particular fashion, the entire solid or the entire structure which is obtained is known as either solid, or it is also known as lattice, or it is also known as crystal, or it is also known as crystal lattice, anything we can say among the four. Now, let us change or let us elongate or extrapolate this unit cell in terms of 3 dimensions, that is x plane, y plane and z plane. Let us divide this into 3 parts. So, let us extrapolate this one. Let this be the x axis, let this be the y axis, and let this be the z axis. These are the 3 axes, and let the angle between x and y plane be alpha. Let the angle between x and z plane be beta, and the angle between y and x z plane be gamma. It can be on any of the 3, and we have 3 edge length, 3 distances. As you know, in a cube, or since we are treating a unit cell to be a cube, so in cube we know that all the sides are equal. All the sides, whether it be length, breadth or height, all the 3 sides are equal. And since all the 3 sides are equal, then we treat the single side or all the sides to be equal, and it is represented as edge length. Since all the sides are equal, so it is known as edge length, and edge length is normally represented as A. It is represented as A. So, this distance, let this distance be A, let this distance be, and this distance be C. So, we have 3 interplanar angles, that is alpha, beta and gamma, and we have 3 interplanar sides or length, that is A, B and C. These are the 3 sides. So, we have 6 parameters alpha, beta, gamma and A, B and C. On the basis of these 6 parameters, we will govern the 7 Bravais systems or 7 Bravais lattices. We will govern this one. So, now, next thing. Next one would be types of unit cell. Types of unit cell. Type of unit cell. So, basically unit cells are of 4 types. Basically unit cells are of 4 types. First one is simple or primitive unit cell, simple or primitive unit cell. The second one is body centered unit cell, body centered unit cell. It is also known as BCC arrangement. Then next is face centered unit cell, also known as FCC arrangement, and the last one is end centered or edge centered unit cell. Also called ECC arrangement. So, these are the basically 4 types of unit cells. Now, the simple or primitive unit cell is further divided into 7 categories or 7 different types. First one is cubic unit cell, then is tetragonal unit cell, orthorhombic unit cell, rhombohedral unit cell, monoclinic unit cell, hexagonal unit cell, and triclinic unit cell. These are the 7 different types of primitive or simple unit cell, and these 7 types are collectively known as, because it was discovered by August Bravis. They were discovered by August Bravis. So, they are known as 7 Bravis lattices, or they are known as 7 crystal systems, or they are known as 7 crystal habits. They are known as 7 Bravis lattices, 7 crystal systems, or 7 crystal habits. These are the further classification of the same. Next one is, let us discuss the types. First one is simple or primitive unit cell. Simple or primitive unit cell. Simple or primitive unit cell. In case of simple or primitive unit cell, we have the constituent particles, the constituent particles can be either atoms, or it can be either molecules, or it can be ions, it can be any one of the 3. The constituent particles are found only on the 8 corners. They are only found only on the 8 corners and nowhere else, only on the 8 corners. Like we have, let us have an example of primitive or simple unit cell. Let this be a unit cell, and we have 8 corners, and the particles are arranged only on the 8 corners. These are the constituent particles. These are the particles on the 8 corners. Particles on the 8 corners. Next one is face centered unit cell, also known as FCC arrangement. Face centered unit cell, also known as FCC arrangement. The constituent particles are present on 8 corners, and also plus one particle at center of 6 faces. We have one particle at the center of 6 faces. Let us have a schematic diagram of the same FCC arrangement. And in FCC arrangement, we have 8 particles at the corners, and at the center of 6 faces. So, these are the particles at 8 corners, and these are the particles at face centers, 6 face centers. Next, next is third one, body centered unit cell, also called BCC arrangement. So, in case of BCC arrangement, we have constituent particles at 8 corners plus 1 particle at body center, 1 particle at body center. Means, let us have a schematic diagram of the same. Now, if we are arranging this one, so we have 8 particles at the corners, and we have 1 particle at the body center. So, these are the particles at 8 corners, and this is the particle at body center. Thank you, class.